Yesterday we talked about area of a triangle. Today we are moving on to area of trapezoids. And we're going to throw in parallelograms. Areas of trapezoids and parallelograms. Yesterday, we really emphasized when we're talking about triangles that we talk about a triangle formula being area equals base times height divided by 2. This being that rectangle dividing in half, which we've translated into area equals 1/2 times the base times the height. Both of these are equivalent equations. You can use either one. This idea is that the base and the height of really anything that we're talking about in math. If we're using the vocabulary of base and height, typically in a geometry unit, if we're using the vocabulary of base and height, they are going to be perpendicular to each other. And perpendicular is a fancy name for 90 degrees. We talked a lot, there's a little bit of review. We talked a lot about this symbol. This symbol tells us that it is 90 degrees. It is our clue because it touches the base and the height. This is going to be really important today, which is why we definitely have to know this. The good news is this: you do not have to memorize today's formulas because the formulas we're talking about today are on the MCAP formula sheet. Now, when we take this in paper, we used to pass it out, but on the computer screen, they always have this little tab that says formulas. If you click into that tab, they're going to provide to you these formulas. Area equals 1/2 the height times the quantity b sub 1 plus b sub 2. Now, sometimes, because of the commutative property, this is times this quantity, they're going to rewrite it as 1/2 times the quantity, base sub 1 plus base sub 2, and they're going to put the h on the other side. You're still talking about 1, 2, 3 factors, 1, 2, 3 factors. These are equivalent equations as well. And I know you're like, whoa, that looks crazy. When you look at a trapezoid, and this is the typical trapezoid that we imagine, I'm just going to start here. I'm going to digress in just a second. There's a little perpendicular, and there's a little perpendicular. So a trapezoid has this single pair of parallel sides. These are the symbols for parallels. It means if I stretch this out infinitely, and if I stretch it out infinitely, this one as well, this line and this line, if I stretch it out, it will never intersect. They are parallel, compared with perpendicular, where they come to a right angle here. So here, this height is perpendicular to both this side and this side of this figure, making them both bases, because the base and height are perpendicular. So all trapezoids have two bases. Now, because you're adding them, the commutative property tells me that it doesn't matter which one I label base sub 1 and base sub 2. As long as I pick one, I could call this base sub 2 and this base sub 1. It doesn't matter. The commutative property, I'm still just going to be adding those numbers. Now, the definition of a trapezoid is that it has one pair of parallel sides. So we tend to imagine it like this, which is really an isosceles trapezoid because it has an equal pair of sides here. But some trapezoids are going to look like this. Okay, there's your right angles. There's your height. It's actually a side now. Rather than dropping that inside of it, just like we did with the triangles, it's on the outside. It's part of the perimeter now, unlike this one. It's still got a base sub 1 and a base sub 2 here, except now all of them are sides. So it's important to recognize that as long as you have a pair of parallel sides, and you have 1, 2, 3, 4 sides, 1, 2, 3, 4 sides, you've got a trapezoid on your hands. The book will take this and rotate it. Yay, right? Like this. It's still got 1, 2, 3, 4 sides. It's still got a pair of parallel sides, and it's still rotated like this. Now, this is going to come back to crazy formulas you've never seen before but should be able to use. Nutso formula. You don't have to memorize it. It will be provided to you, okay? But you do have to be able to substitute and solve. So let's put in some numbers. This is 8. Let's make this side 15, and this side 10, and this side 7. I have to be able to say, well, the area of that trapezoid is half times the height times the quantity b sub 1 plus b sub 2. This is getting into FSSU, right? Writing the formula. Now we're going to substitute. The 1/2 comes down, multiply by the height. The height here is perpendicular to the two bases. The height here is 7 times the quantity, 10 plus 15. Well, what's 8? You don't need 8 unless you're doing the perimeter of this figure. The area is now 1/2 times 7 times 25. All I did was the inside the parentheses. Now, I could take half of 25 and multiply by 7. I could take half of 7 and multiply by 25. I'm going to get out my calculator. Help me out here. I'm going to take, I don't know, half of 7 and get 3 5/10 times 25. It's going to be like 80 something, I think. 25 times 3 5/10, 87 5/10 units squared, since it wasn't specified here. All I'm doing is substituting and following through with the process. It looks more scary than it really is. Now, I'm going to do the same problem another way. I'm out of space. I'm just going to kind of slide this up. I'm going to draw the exact same parallelogram, trapezoid, sorry. The exact same trapezoid. And I'm going to put in the exact same measurements. I'm going to say, is there another way to do it? And the answer is yes. We could do this with a combined figure approach. And we talked about that by doing the FFSSU, where this one's really kind of big idea. If you don't look at this and see trapezoid and go, oh, I can substitute it into this formula, you might say, well, I see a triangle, right? And if this is 10 and this is 10, then this would be 5. I see a triangle, and if this is 7, this is 7. Right? I have all the dimensions I need there, a height and a base. And then I see a rectangle that's 10 by 7. So I could say the area is going to be the triangle plus the rectangle, which is going to be, I'm going to call this 1, that 2, 1/2 base sub 1 height sub 1 plus base sub 2 height sub 2 times base sub 1 of the triangle. So these are interchangeable, 7 and 5. One's the height, one's the base, 7 times 5 plus 10 times 7. Area equals half of 5 is 2.5, and 2.5 times 7, putting it in my calculator, 17.5 plus 70. Area equals 87.5 units squared. So you can kind of juxtapose using the trapezoid area, the area formula, with splitting it into a triangle rectangle. Now this isn't always they're not always gonna give you enough information to do this. The power is, you know, if this was an isosceles trapezoid, then you'd have 2 triangles and a rectangle. That's a lot more work than this substitution. Don't say, I'm never gonna learn this because it looks too scary. This really does simplify your life when you're dealing with a typical trapezoid. Those are the basics. On tonight's homework, you're going to be writing this formula, substituting and solving over and over and over again. Your work should look like my work, writing the formula, showing the substitution and solving. And I will say this, on the homework, check the units. I do believe that on almost all the problems on the homework, there's different units. that has to be converted first before you actually solve them. The last thing I'll throw into here is the area of a parallelogram, which is going to make you laugh. It's the area equals base times height. Typically, when we say the word parallelogram, we imagine something like this or something like this. It's kind of like a rectangle that's been pushed over or a square that's been pushed over. That's kind of what we imagine. Just like in a triangle, sometimes that height is going to be out here. That would make this the base and this nothing. If they label it, it's just there to mess with you. Sometimes they will drop that height on the inside. You'd see I could have dropped it here. I could have dropped it here. It's the same height. This would be the base. It's just base times height. It's the same as your rectangle formula. Now, in part 2, I'm going to explain why. And in part 2, you're going to need this worksheet that I've given to the teacher to pass out.